We currently have a single point of failure in our application. If the end user were to type in a value here that is not a 32-bit unsigned integer, then the application will crash completely. For example, if they were to type in bacon, the app will stop running, which is another word for crashing, and then throw this error with this message here that we provided in the expect statement. What we need to do is to provide the end user with a feedback loop telling them that they've entered a value that is not a number, at least not a 32-bit unsigned number, and then have them try entering the number again, and then have the app continue running gracefully. So that's how we handle invalid input from the end user. So what options do we have to solve this problem? Well, let's look at the pattern that we've used thus far in our application. Down here on line 27, we use the Rust feature called match. So just to dive a little bit more on what match actually is. So think of match as a pattern matcher, but it is also a control flow operator. And it allows you to compare values against a series of patterns and then execute code based on which pattern matches. In this case, the guess. Well, in the case on line 27, we are matching the user's guess and we're comparing that to the secret number. And then based on if it's lower than the secret number, we give them feedback. If it's greater, and we give them feedback, etc., etc. Let me use a graphical representation of what a control flow is. It is essentially a if-else then type situation on how to proceed based on the situation, execute certain code. So let's look at this zombie map here. Okay, let's say you're coming from down here on the lower left-hand quadrant. Okay, and you make it this far and you see all these zombies and chaos over here, right? Well, if you want to survive the zombie apocalypse, most likely you are not going to proceed forward unless you're planning on killing some serious zombie that day. But if you're not prepared for that, then obviously you're either going to go this way or that way or turn around and head back the other way where you came from, right? So those are the decisions that we make based on matching the pattern that we have, okay? So we match these patterns that we see before us here, and if we do not want to encounter zombie and violence that day, then we execute code to go in a different direction, all right? So essentially that's what a control flow is. And that's essentially the match keyword, okay? So what we can do is we can match the input and see if it's a number or a string. If it's not a number type, then we can do something to keep the program running and provide a user with a feedback loop. So on line 26, let's put the match keyword right there, okay? To the right of the assignment operator, which is the equal sign here. And then we don't want this expect statement anymore because it's a do or die situation. What we want is a more elegant way to handle our flow, right? Our programmatic flow to ensure that we can handle invalid inputs and minor errors, okay? So if I were to hover on the parse keyword, the first line you see here gives you the signature of this function. And if you look at this here, you look at that symbol there, the dash and the greater than sign. That symbol means the return type, the return data type of this particular function, the parse built-in function. As you can see, this function returns a result type. So in a result type, you get an enum, sort of like we did down here with the comparison operator, right? So we can think of an enum as a type that has a value from a list of possible variants. For example, less than, greater than, or equal to, right? So that's what an enum is it's a type that has multiple variants inside of this object that we can select from. In this particular case, it's less than, greater than, or equal to. In the case of the built-in parse function, the options inside of the enums that we have are, if you look at the regular documentation, okay, so you can see the code hinting here. And then error. Again, look at the IntelliSense code hinting that we get. Okay. Now, there's more work that we have to do in here with the parse. So we need to group these enums together, and we do that by using the open curly brace and closing curly brace like we did down here. And because it is a statement, we need a semicolon. So now we are going to go into what we refer to as lambda functions or lambda expression in Rust. And this is a syntax that is common in many computer languages. So let me do some typing and then we'll come back to the code and we'll come back to explaining. Okay, so this syntax here with the equal sign and the greater than symbol. Now, this is different. Okay, this is the equal sign. In parse, the return type is dash and then greater than. The lambda expression or fat arrow or lambda function is an equal sign and greater than. Okay, so this is the algebraic concept of a closure. So what the heck is a closure? Well, for the time being, think of a closure is the ability for the function to capture the enclosing environment. In this case, is num. Okay, and it can also capture the value outside of its scope, outside of this function here. It can read anything outside of its own enclosed environment, but not the other way around. Okay, that's why it's called a closure. It closes in on itself. Now, if that doesn't make any sense, don't worry. It'll make sense once we continue this tutorial series. So this syntax is really valuable in that it makes it convenient to act upon the enum value inside of an enum like this here. And so in a one-liner like this, we do not need curly braces. However, like on line 32, it was a multi-line, actually on line 35, it was a multi-line, then we need curly braces. So for error, I want to throw an error on everything that is not a 32-bit integer. So if the end user did not type in an integer, I'm going to tell them, you did not type a number. Must be a number. Okay, and I'm going to put in, added extra line to make it easy to read, the extra return, a new line there to make it easier to read. What happened there was that the IDE automatically formatted the code for me. And once I print out that line, I need to tell the compiler to continue running the application So what does continue mean in this particular case? So if they did not type in a number, continue to offer them the opportunity to type in a number by running this part of the enum. Okay, this underscore here is a catch-all value in Rust, meaning that I want to throw an arrow on everything except for a number type. In this particular case, an unsigned 32-bit integer, a positive number, right? And so that's pretty much it. Let me move this line down here. Give a little space right here. Okay. All right, let's go back to the console and see how we did. Let's clear this out. Again, that CR is my alias for cargo run. Okay, so let's type in something that is not a number. Okay, let's type in a special character, an asterisk. You did not type a number, it must be a number. Okay, so we know the secret number is 1. Let's try 0, too low. Let's try 5, too high. Let's try the correct number this time, 1. Exact match, we won. Okay, let's go ahead and remove the secret number because that was for development purposes only. That is the secret number. We don't need that anymore now that we have what we need. Okay, so the ability to ensure that the application can gracefully handle unexpected input and minor error is hugely important. For example, looking beyond the basic application here, let's say a couple of years from now, you work on writing software for an airplane, right? And so if an airplane loses its primary way to communicate on the radio, then we certainly do not want to remove the ability of the airplane to land, right? So we can handle the no radio situation. If the airplane loses primary communication, we can go to secondary and tertiary way to communicate with ground control or with air traffic control. But certainly we do not, just because we lost communication, we should not inhibit the pilots from the ability to land that aircraft and control and using the flight controls, right? So thinking beyond the basic scope of this, that's where graceful error handling and unexpected input becomes very important. That's it for now. In the next episode, we will review what we've learned thus far. Thanks for watching. See you next time.